Right now, you are sitting on a rock hurtling through space at 67,000 miles per hour, inside a galaxy that is itself moving at over 1,000,000 miles per hour, and nobody asked your permission. But here's what will genuinely break your brain. Scientists don't actually know where all of that motion is going, because the universe has an edge. And what's past that edge? Nobody knows. Not a single physicist, not a single telescope, not a single equation has given us a clean answer. And the more we look, the stranger it gets. Stay with me, because what we've already discovered floating out there in the dark makes this question even more terrifying and fascinating than you think. Let's start with what we do know. Because even the confirmed science reads like fiction. We know the observable universe stretches roughly 93 billion light years across. That's the part we can see the bubble of space from which light has had enough time since the Big Bang to reach us. But here's the twist. The universe is expanding faster than light can cross it. That means right now there are galaxies racing away from us so fast that their light will never ever reach Earth. We will never see them. They are real, they exist, and they are permanently invisible to us. We are already blind to a massive portion of our own universe. So when you ask what's past the edge, you first have to ask, which edge? The edge we can see. The edge of the observable universe isn't a wall. It's not like driving off a cliff. It's more like a horizon. Walk toward it and it moves. The boundary exists only because of the speed of light and the age of time. Beyond that horizon, current physics tells us the universe almost certainly continues, possibly forever. But continues as what is where things get genuinely mind-bending. If the universe is infinite. One major possibility supported by cosmological models is that the universe simply never ends. It keeps going in all directions. And here's the deeply unsettling part. If it is truly infinite, then every possible arrangement of matter must repeat somewhere out there. That means there is, statistically, another version of Earth. Another version of you. An infinite number of them. In fact, some almost identical to your life. Some differing by a single decision. Some differing so radically they're unrecognizable. This isn't science fiction. It's a direct mathematical consequence of an infinite universe with finite types of particle arrangements. The many worlds of physics aren't in another dimension, they might just be very, very far away. If the universe is finite. But what if the universe is finite? What if it does have an edge? Then the next question becomes, what is that edge made of? And this is where physics essentially throws its hands up. The honest answer is, we don't have the tools to know. Some models suggest the universe curves back on itself like the surface of a sphere, meaning if you traveled in one direction long enough, you'd eventually return to where you started with no wall, no boundary, no edge at all. Just an endless loop. Others suggest the universe could be shaped like a saddle, open and infinite in structure. And then there are the multiverse theories. Beyond the edge, the multiverse. Some of the most credible cosmological models built on real math, not imagination, suggest that our universe is a bubble. One bubble among potentially infinite others, each formed from a process called eternal inflation. During the earliest fraction of a second after the Big Bang, space expanded at an incomprehensible rate. Most models of inflation suggest it never actually stopped everywhere it keeps happening in regions beyond our reach, constantly spawning new universes like soap bubbles forming in a foam. Each bubble universe would have its own physical constants, its own rules of physics, possibly its own kinds of matter and energy that bear no resemblance to what we know. In some of those universes, the force of gravity might be slightly stronger, and stars collapse into black holes before planets ever form. In others, the electromagnetic force is slightly weaker, meaning atoms never hold together, and matter as we know it never assembles. The overwhelming majority of bubble universes that could exist would be dead, empty, structureless. We exist in one of the rare ones where the numbers lined up just right for complexity to emerge. For stars, for carbon, for you watching this video right now. That's the fine-tuning problem. And it haunts physicists. What we've seen that already challenges everything. Here's what makes this even more gripping. We haven't even needed to leave our cosmic neighborhood to find things that shatter expectations. Consider the rogue planet's worlds with no star, no system, just drifting alone through the void of deep space. We've confirmed their existence. Planets ejected from their home systems by gravitational chaos, now wandering in permanent darkness at temperatures capable of raining molten iron from their upper clouds. These are real places, real worlds. And they remind us that the universe is under no obligation to be hospitable, organized, or predictable. Consider the exoplanets orbiting so close to their host stars that entire rocky surfaces melt and vaporize, then rain back down as gravel. Worlds where one side is a permanent inferno and the other is frozen near absolute zero. Worlds being slowly consumed by their own stars, piece by piece, destined to dissolve into a gas cloud within the next few million years. And that's just what we can see. That's just the thin slice of reality our instruments can detect. The most honest answer science has. If you stripped away all the comfort and gave the raw, unfiltered scientific consensus, here it is. We don't know what's past the edge of the universe because we cannot observe it, and our physical laws may not even apply there. The rules that govern quantum mechanics, gravity, electromagnetism, they were written inside this universe, tested inside this universe, and may be completely local to this universe. What's outside may not follow any rule we've ever imagined. It might not have space. It might not have time. The word outside itself may be a category error, like asking what's north of the North Pole. The question assumes a structure that may not exist past a certain point. And yet, we keep looking. The James Webb Space Telescope is currently sending back images of galaxies formed just a few 100 million years after the Big Bang. With every image, we are literally looking back in time, seeing the universe in its infancy. And with every new discovery, we're finding that the universe was more complex, more structured, more surprising than our models predicted. Galaxies that shouldn't exist yet. Stars that are older than expected. Structures so massive that they strain the standard model of cosmology. The universe is not done surprising us. And the edge, whatever it is, wherever it is not an ending. It might be the beginning of something so alien and vast that we don't yet have the language or the mathematics to describe it. That's not a limitation. That's an invitation. Hit subscribe if this kind of deep universe exploration is what you're here for, because we are just getting started. Next up, the objects in space so extreme that even the laws of physics begin to break down around them. You don't want to miss it.